You may recall learning about vertical and horizontal asymptotes in college algebra or pre-calculus, especially when dealing with rational functions like the one that's graphed here. We can actually use limit notation to denote these types of asymptotes. So let's do this. If we were looking here at this, we'd say, here we could say the limit as x approaches negative infinity, so as your x values are approaching negative infinity of the function is getting closer and closer to 0. Over here, same thing, as your x values are approaching infinity, the function is getting closer and closer to 0. So this shows our horizontal asymptotes. When we have as x is approaching infinity or negative infinity, that is the end behavior of the function if it's approaching a specific value. And so those are our horizontal asymptotes. For the vertical asymptotes, this would look like this. The limit as x is approaching 0 from the right-hand side. So as x is approaching 0 from the right-hand side, that function is approaching infinity, negative infinity. And up here, the limit as x approaches 0 from the right-hand side, the function is approaching positive infinity. Let's summarize this. The line x equals a is called a vertical asymptote if any of the following are true. The limit as x approaches a of f of x is infinity, or if it's you're approaching a from the left or the right, you're approaching infinity, or as you're approaching a, it goes towards negative infinity, or from the left or the right side, it's going towards negative infinity. So remember a vertical asymptote, so that's going to occur when we have a limit in the form of a non-zero number divided by 0. So non-zero means like 5 divided by 0, 4 divided by 0, 2, negative 3 divided by 0. So we talked about an indeterminate form in the last section of 0 over 0. This form for vertical asymptotes is having a number divided by 0. That is not 0. And then for horizontal asymptotes, the line y equals c is called a horizontal asymptote of f if any of the following are true. The limit as x is approaching positive infinity or negative infinity, the function is approaching a constant number. Let's look at an example of this graphically. So evaluate the following limits. The limit as x approaches 3 from the right of 2x over x minus 3. So we can see here, if I put 3 in for x, I'm going to get 6 on the top, 2 times 3. And then on the bottom, I'm going to get 3 minus 3 is 0. But again, we're not talking about what's happening at 3. We're talking about what's happening as I'm approaching 3 from numbers that are larger than 3. So if I'm putting numbers that are larger than 3 in here, this is going to be a positive number, but it's going to still be approaching 0. So the reason we need to keep in touch with that, if it's positive or negative, is because that's going to play a role into if this is positive infinity or negative infinity. So the reason that when you divide by 0, we go towards positive or negative infinity, if you think about it, think about division. So if we had something like 6 divided by 2, that says how many times can 2 go into 6, or how many pairs of 2 are in 6. So there would be 1 pair, 2 pairs, 3 pairs of 2 are in 6, okay? Now, if I'm talking about how many pairs of 0 go into 6, or groups of 0, well, that's an infinite amount. There is an infinite amount of zeros that can be put into 6. So that's why these go to infinity or negative infinity. So this limit is infinity. If I look over here, this is approaching 3 from numbers that are smaller than 3. So again, if I just substitute in that 3, I'm going to get 6 in that numerator, and I'm going to get 0 in that denominator. So I'm in that form of a non-zero number divided by 0. So this is going to be a vertical asymptote. So I need to figure out, okay, is this going towards positive or negative? So if I'm looking at numbers that are smaller than 3 and I subtract 3 from it, so for example, 2 is smaller than 3, that's going to give me a negative value. So that we can then conclude that this limit is going towards negative infinity. So because of the fact that on the right I'm going towards positive, on the left I'm going towards negative, I would say that this limit does not exist. But we will still see there's a vertical asymptote at x is 3. Okay, let's look down here at another example. So the limit as x approaches 0 from the right. So if I right now plugged 0 in to this function, I'm going to get 1 over 0 squared, so that's going to be a positive, times 0 plus 4, which is 4. Again, this is a positive number, but anytime when you square something, it always becomes positive. So I've got, this is going to be going towards positive infinity. Over here, 1 minus 0, that's still going to be that positive 1. And then over here, at 0 squared, so even numbers that are smaller than 0, so that are coming from the left-hand side, like let's say negative 0.5, when you square them, it's still going to be positive. So this also is going to be going towards positive infinity. So since it's the same on the left and the right, we can say the limit as x approaches 0 is infinity. All right, let's use the graph below to evaluate these specific limits. So if I am looking at the limit as x approaches infinity of this function p of x. So as your x values are approaching infinity, so as this is going to get really, really big, you can see this graph is getting really, really close to 2. On the other side, as your x values are approaching negative infinity, we'd say this is getting really, really close, also to 2. So this is, it means, and you can kind of see it written here, drawn in here in this orange, this is a horizontal asymptote at y equals 2. We can also see that we have a vertical asymptote here, right here, and if I was looking at those limits, I'd say looking at the limit as x approaches 1 from the left, we're approaching negative infinity, and from the right, we're approaching negative infinity. So there's a vertical asymptote at x equals 1. All right, let's do the same thing over here. So the limit as x approaches infinity of q of x. All right, so as x is approaching infinity, well, that's just going to continue going up and up and up. So that's going, the function's just going to end up approaching infinity. If I look at it from the other side, though, as x is approaching negative infinity, you can see this is getting closer and closer and closer to y equals negative 2. So there is a horizontal asymptote at y equals negative 2.